Section 5.4, Solving Radical Equations and Inequalities. This video is going to focus on the equations. The next part of the video will focus on inequalities. So the first vocabulary term, radical equation, it's an equation where the variable is under a radical. That shouldn't be too mind-blowing of a definition. An example would be something like 2 times the square root of x plus 1 is equal to 4. That would be an example of a radical equation. The steps for solving radical equations are pretty simple, actually. It's really no different than solving any other type of equation. We're just now expanding it to radicals, so square roots, cube roots, fourth roots, whatever. Okay, so step number 1, isolate the radical. Get the radical by itself. So anything outside of the radical, whether it's in front or behind, needs to go away first. Once we do that, then we're going to raise each side to a power to eliminate the radical. So in this example here, number 1, we have a square root, so we would square both sides. In number 2, we have cube roots, so we'll cube both sides, things like that. Okay, and then step number 3, solve what's left. And with the goal at the end is to get down to just the variable. So it's x equals or y equals, something like that. Okay, so let's try a couple here. Number 1, solve the equation. 2 times the square root of x plus 1 is equal to 4. This is the one we had in the example. So we have something out front, that's 2 times the square root. So to undo multiplying, we need to divide. We're going to divide both sides by 2. The 2's cancel out, so I'm left with the square root of x plus 1 is equal to 4 divided by 2 is 2. So we've got the radical by itself. Now we need to get rid of it. How do we get rid of a square root? Well, we're going to square both sides. Okay, so we'll raise both sides to the power of 2. So on the left-hand side, the square and the square root cancel each other out. You're just left with what's underneath, x plus 1. On the right-hand side, 2 squared is 4. So we got x plus 1 is equal to 4. And then this is just a one-step equation. We're going to find out that x is equal to 3. And that would be your answer. Number 2, the cube root of 2x minus 9 minus 1 is equal to 2. So the minus 1 on the end is not underneath the radical. And that's what this little hitch on the end of the radical symbol is for. It shows that the minus 1 is not part of the radical. Okay, so the minus 1's on the outside, so we need to get rid of that first. And do that by adding 1 to both sides. So we'll have the cube root of 2x minus 9 is equal to 2 plus, and that shouldn't be a 3, that's plus 1. 2 plus 1 is 3. Oh my goodness, 3. And then we'll need to get rid of the radical because the radical is now by itself. To undo a third power, we're going to raise both sides to to get rid of the third root, we're going to raise both sides to the third power. Okay, so the cube root and the cube cancel each other out. We're left with 2x minus 9 is equal to 3 to the third power. Most people right off the bat will say 9, and that is incorrect. 3 to the third power is 27. 3 times 3 times 3. Okay, so now we got a two-step equation from here. We'll add 9 to both sides, so 2x is equal to 36, and then we'll divide both sides by 2, and we're going to find out that x is equal to 18. Okay, so there's a couple of examples for radical equations, solving radical equations. Get the radical by itself, get rid of the radical, and then solve what's left. Let's try a story problem. The mean sustained wind velocity in meters per second of a hurricane can be modeled by, and here's your model. It's going to be V of P is equal to 6.3 times the square root of 1013 minus P. Okay, so V of P is equal to 6.3 times the square root of 1013 minus P, where P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure when the mean sustained velocity is 46.2 meters per second. So we have two different variables. We have this V of P, and then we have P. It says P is the air pressure, V of P is the velocity. It tells us a velocity, so we're going to substitute this 46.2 into V of P. So it's going to be 46.2 is equal to 6.3 times the square root of 1013 minus P. And we're going to solve for P because that's what it's asking for. Finding the air pressure. Okay? So the square root is not by itself. We need to get rid of that, or the number in front, by its first. Okay? So we're going to divide both sides by 6.3. So the 6.3's on the right-hand side cancel. We're just left with the square root of 1013 minus P. 46.2 divided by 6.3 is approximately 7.33. Okay? And then we need to get rid of the square root. We get rid of the square root by squaring both sides. We'll square both sides. 7.33 squared is approximately 53.7. and then the square root of 1013 minus p is just 1013 minus p. The square and the square root cancel each other out, so we're just left with what was underneath. Okay, we're going to two-step equation from here. Going to subtract 1013 from both sides. 1013, that leaves me with negative 959.3, and that's equal to negative p, because those cancel. Okay, and then obviously we just need to flip the signs here so that p is equal to 959.3, and the label here was millibars. So 959.3 millibars. So that story problem looked a little daunting, but really it wasn't that bad, just because, you know, people see a lot of words and labels and numbers and they freak out. It's not that big of a problem. Just figure out what the variables represent, figure out what they're giving you, and then what you need to find, and then go ahead and do that. Okay? The next vocabulary term in section 5.4 is extraneous solution. And we've seen extraneous solution before. It's a solution that is not a solution to the original equation. Okay? Usually this happens, or we're going to come across possible extraneous solutions when we have a radical equation where x is underneath, but you have another x that's not underneath. Okay? That's when you should be concerned that there might be an extraneous solution. Okay, so let's go ahead and solve this. The rules are still the same. We got to get the radical by itself, and the radical is right here, and it is by itself. So we can go ahead and get rid of it right away. Okay, to get rid of a square root, we need to square both sides. And when we square both sides, we need to square all of it. Okay, so x plus 1 squared means x plus 1 times x plus 1 equals 7x plus 15. We can FOIL this. X plus 1 times x plus 1. When you FOIL it out, it gives you x squared plus 2x plus 2 is equal to 7x plus 15. So we've got a quadratic equation now. Okay, it's a quadratic function. So we'll need to get everything to one side. So we'll subtract 7x, we'll subtract 15 minus 7x. So we've got x squared minus 5x minus 13 is equal to 0, because remember it's got to be equal to 0. And let's see, this one can be factored. So let's go ahead and factor this. So it's got to be equal to 0. We're going to have x and x because the number in front is 1. Okay, two numbers that, and you know what, I just realized I made a mistake. This isn't going to be plus 2, this is going to be plus 1, which makes this minus 14. Okay, so now we need two numbers that multiply together to get 14 and add together to get 5. Sorry, negative 14 and negative 5. Those two numbers are negative 7 and positive 2. Okay, so then that leaves us to our solutions, x equals 7 and x equals negative 2. Now, when it says to check for extraneous solutions, what that means is go back and plug each of these two solutions back into your original equation, because one or both might not work. Okay, so let's start with 7. Okay, so we're going to have 7 plus 1 is equal to the square root of 7 times 7 plus 15. We're going to see if that's true. 7 plus 1 is 8. Let's see, 7 times 7 is 49. 49 plus 15 is, that is 64. So this 8 is equal to square root of 64. That is 8. That one works. Okay, so 7 checks out. We need to check negative 2. We'll do that one in orange. Okay, we're going to do the same thing. So negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Okay, so negative 2 plus 1 is negative 1. 7 times negative 2 is negative 14. Plus 15 is 1. Now, yes, when we talk square roots, there are two answers, positive and negative. But if it doesn't have a negative square root out front, it's talking about the positive one. Or if it doesn't say plus or minus, it wants the positive one. So the square root of 1 in this case is only 1, and negative 1 obviously is not equal to negative 1. So negative 2 is not an answer. It is an extraneous solution, meaning that 7 is your only answer here. All right, let's try another one. This one's going to be a little more difficult. Number 2 here. Let's go with the square root of x plus 2 and then plus 1 is equal to, so the plus 1's on the outside. Okay, so the x squared of x plus 2 plus 1 is equal to the square root of 3 minus x. Now, when we've got a problem like this, when we've got more than one square root, step number 1 says isolate the radical. The question then becomes which one? And my answer to that is pick one. This one on the right is already isolated, so I'm going to choose to get rid of that one first. Okay, so I'm going to do that by squaring both sides, and I need to square everything. Okay, so the right-hand side is going to be pretty easy. It's just going to be 3 minus x. Now the left-hand side, we need to FOIL. Okay, so this is going to be square root of x plus 2 plus 1. That's going to be there, times the square root of x plus 2 plus 1. Okay, so we need to FOIL. This is going to be a little messy, so just kind of hang in there with me. And let's see if we can't make this as painless as possible. So the first term, square root of x plus 2 times the square root of x plus 2 gives me the square root of x plus 2 squared. Okay, x plus 2 times, or square root of x plus 2 times 1 is just the square root of x plus 2. The inners, same thing, plus square root of x plus 2 plus, and then our last 1 times 1 is 1. Whoops, that's not supposed to be a t, that's a 1, equals 3 minus x. Now, something nice happens here with this term. Square root of x plus 2 squared is just x plus 2. X square root of x plus 2 plus the square root of x plus 2 is actually 2 square root of x plus 2, combining radicals. And then plus 1 is equal to 3 minus x. Okay, so we've eliminated one radical. Now we need to get rid of the second one. Okay, so let's get everything to one side that doesn't have a square root. So we're going to subtract the x, subtract the 2, subtract the 1, subtract 1, subtract 2, and subtract x. Okay, so on the left-hand side, we're going to have 2 times the square root of x plus 2 is equal to, so 3 minus 1 minus 2 is, well, that's actually 0. That's a good thing. These all cancel out. And then negative x minus x is equal to negative 2x. Okay? So now we've cleaned up the one side. Let's get rid of the other radical. So this 2 out front needs to go away. I'm going to do that by dividing both sides by 2. Okay, so those go away. Remove that. So we're going to have the square root of x plus 2 is equal to negative 2 divided by positive 2 is just negative 1, so negative 1x. Okay, so the radical is by itself. Let's get rid of it now. We're going to square both sides. Okay, so we'll have square root of x plus 2 squared is just x plus 2. The square root and the square cancel each other out. Negative x squared means negative x times negative x, which is a positive x squared. Okay, now we've got a quadratic. Let's get everything to one side. Let's move the x this way, the 2 this way, so we'll have 0 equals x squared minus x minus 2. Okay, can this be factored? The answer is yes. Okay, so we'll have 0 equals, we'll have, let's see, two numbers that multiply together to get negative 2 and add together to get negative 1. Those two numbers are negative 2 and positive 1. Okay, so x minus 2 times x minus 1, which gives me my solutions of, whoops, let me get rid of that 0 equals. We're going to have x equals 2 and x equals negative 1. Okay, once we get those two numbers, we will have to check those in our original equation to see if one or both are extraneous. Let's start with the square root of x plus 2 plus 1 equals the square root of 3 minus x. All I'm doing there is just rewriting the problem a little lower so I don't have to scroll back and forth. Let's start, though, by checking with 2. Okay, so we'll have the square root of 2 plus 2 plus 1 equals the square root of 3 minus 2. Okay, so square root of 2 plus 2, that's the square root of 4. The square root of 4 is 2 plus 1. 3 minus 2 is 1, so this leaves me with the square root of 1, which is actually just 1, so I'm going to erase this, and we're just going to put a 1 there. So 2 plus 1 equals 1. Obviously, that doesn't work. So the apparent solution of 2 is not an actual solution to our problem because it doesn't work out. Let's check negative 1. Okay, so we'll have the square root of negative 1 plus 2 plus 1 equals the square root of 3 minus negative 1. Make sure you don't omit that negative sign. Okay, so negative 1 plus 2 is 1. Okay, so we'll have the square root of 1, which is 1 plus 1 equals, let's see, 3 minus negative 1, same thing as the square root of 4. Square root of 4 is 2, so I'm going to replace this with a 2. 1 plus 1, that definitely is 2, so the only answer here is negative 1. So negative 1 is your only solution there for example number 2. Okay, one last thing in this part of the video, solving equations with rational exponents. So rational means fractions. Okay, so you can see a couple of examples there on the screen, 1 and 2. How do we solve something with a rational exponent? So step number 1, isolate the base. The base is the exponent and whatever it's being raised to. Okay, this plus 2 is not part of the base, so this is what would need to go away first when we solve. Okay, once we get the base by itself, we're going to raise the equation to the reciprocal power. Okay, so if we're going to, like with this one, so let's do number 1 here as we're going through the steps. So isolate the base. So the base here is 2x. Okay, so the plus 2 on the end needs to go away first. So we're left with 2x to the 3/4 power is equal to 10 minus 2 is 8. Okay, so step number 1, isolate the base, done. Step number 2, raise the equation to the reciprocal power. The power right now is 3/4, so the reciprocal of 3/4, flip over the fraction, is 4/3. So we're going to raise both sides to the 4/3 power. Okay, so what's going to happen on the left side then, 3/4 times 4/3 is 1. They cancel each other out. You're left with just the base, 2x. Okay, if you don't know what 8 to the 4/3 power is, and you can use your calculator, you could also use your half sheet with the table. What you're going to find is 8 to the 4/3 power is 16. Okay, then one last step, because the last step says solve the resulting equation. This is just a one-step equation, divide both sides by 2, and we're going to find that x is equal to 8. Okay, this would be your answer for number 1, x equals 8. Okay, number 2, let's do the same steps. Step number 1, isolate the base. Well, that one's already done for us. Okay, so we don't need to do anything for step 1. The base is already by itself. X plus 6 to the 1/2 power is equal to x. Okay, step number 2, raise the equation to the reciprocal power. The reciprocal of 1/2 is 2, so we're going to square both sides. Okay, also what you're noticing, there's an x on the outside. We might have to check for extraneous solutions here. So let's solve it, and if we get more than one answer, and even if we get one answer, we should go back and check it. Usually though, with one answer, like in number 1, we won't need to check. But with number 2, we're probably going to get 2 answers, so we might have to do some checking at the end. Okay, so 1/2 times 2 is 1, so we're left with the base. X plus 6 is equal to x squared. Okay, let's get everything to one side, so we'll have 0 equals x squared minus x minus 6. This one can be factored. Okay, so let's factor this here. So 0 equals, number in front of x squared is 1. Two numbers that multiply together to get -6, add together to get -1 are -3 and +2. So x minus 3 times x plus 2, which means my two solutions, x equals +3 and x equals -2. So now, once we get our solutions, let's go back and do some checking. Let's start with the x value of 3. Okay, so we had, let's see, so it's going to be x plus 6, so it's going to be 3 plus 6 to the 1/2 power, and we're going to see if that's equal to 3. Okay, so 3 plus 6 is 9. 9 to the 1/2 power is the same thing as the square root of 9. So this really becomes the square root of 9 is equal to 3, and that one checks out. So 3 is one of our solutions, and it might be the only solution. Let's check with -2, and I'm going to use brown for this one. So we're going to have -2 plus 6 to the 1/2 power is equal to, that was x on the end, so it's going to be equal to -2. Okay, so -2 plus 6 is 4, so 4 to the 1/2 power is equal to -2. 1/2 power, again, rewrite that as the square root. Square root of 4 equals -2. Now, again, this is similar to the previous example where, yes, 4 does have 2 square roots, +2 and -2, but this one, since it's not plus or minus out front, or not a minus out front, we are assuming that this wants the positive square root, and it's telling us the negative. So this one would be 2 equals -2, which is not true. So this solution here of -2 is not a solution. Your only answer then is the x value of 3.